No one has ever been to space. Consider this: a rocket carrying Yuri Gagarin with his famous "Let's go" flashes before your mind's eye. But the reality is far more complex. This isn't about the moon landing conspiracy, although its adherents believe the Apollo program was faked. Recall your school geography lessons, specifically the section on the Earth's atmosphere. Remember its layers? First, the troposphere, our home, extending up to 8 to 18 kilometers, depending on latitude. This is where cyclones, anticyclones, and atmospheric turbulence, terrifying to first-time air travelers, originate. Next is the stratosphere, reaching from 11 to 50 kilometers. 19th century scientists mistakenly believed it marked the atmosphere's end. Temperatures here hover around minus 55 degrees Celsius. Recall the shocking footage from Kabul airport. The desperate people clinging to the plane's fuselage had no chance of survival. The stratosphere also houses the ozone layer, shielding us from lethal solar radiation. Above that lies the mesosphere, extending from 50 to 90 kilometers. It was once considered the final atmospheric layer separating Earth from space, but this isn't entirely accurate. The difference lies in flight capabilities. Up to 100 kilometers, air currents can propel vehicles. Above that, only spacecraft can fly. There's no precise definition of where the atmosphere ends and space begins. Thus, interpretations vary. Richard Branson and Jeff Bezos, therefore, haven't technically been to space. They've merely undertaken exorbitantly priced pleasure flights around our planet. Let's leave their ethical considerations aside and ascend further to a layer of absolute silence, the thermosphere. Here, molecules literally chase each other. The vibrant aurora borealis thrives at this altitude. We've also skipped the Kármánline, 100 kilometers above Earth's surface, often considered the invisible boundary between atmosphere and space. It also marks the upper limit of national airspace. Beyond this line, the atmosphere is so thin that aerodynamic flight is impossible. The speed needed for lift exceeds the first cosmic velocity. This division into layers better suits defining means of transportation than space boundaries. Reaching the Kármánline is, however, formally considered a criterion for spaceflight. The first to cross this imaginary line were German V-2 ballistic missiles, designed by Wernher von Braun. Returning to the thermosphere, strictly speaking, this layer begins at 80 to 90 kilometers and extends to 700 to 800 kilometers. Flight here is only possible along ballistic trajectories. This region houses radiation belts extremely hazardous to humans. Temperatures range from minus 73 degrees Celsius to plus 1,700 degrees Celsius. The reason for the thermosphere's heat lies in basic physics. Faster particles release more energy and heat. Ultraviolet and X-rays accelerate these particles to incredible speeds. However, despite the high temperatures, you'd feel freezing cold due to the extremely low particle density. Yet, these high-speed particles are sufficient to damage satellites. So, where does space begin? The upper thermosphere, around 1,000 kilometers above sea level, is characterized by extremely rarefied gases gradually escaping into interplanetary space. Around 3,500 kilometers lies the exosphere, merging with near-space vacuum, which isn't entirely devoid of particles, for example, hydrogen atoms. At these altitudes, another protective layer intercepts harmful UV radiation. Prolonged stays above 500,1000 kilometers are only possible post-mortem. The exosphere also contains hydrogen and helium atoms. The lightest gases rise like steam above boiling water. The exosphere acts as a transition zone between Earth and space. Particles are scarce but incredibly fast, sometimes reaching the second cosmic velocity. The question remains, where does the exosphere end and space begin? Textbooks often cite 10,000 kilometers, but no precise boundary exists. So, who was the first person to leave Earth's atmosphere and enter space? Yuri Gagarin is a common, but incorrect answer. He merely crossed the Kármánline. This doesn't diminish his achievement, but Earth's atmosphere extends much further. Hydrogen and helium are found even on the moon. Consider the NASA specialists involved in the Apollo program. On July 20, 1969, Neil Armstrong and Edwin Aldrin, despite landing on the moon, technically never reached open space. The geocorona, where Earth's influence extends, reaches 630,000 kilometers, meaning the Moon, at 384,000 kilometers, is still within this region. Therefore, the number of people who have left our planet and entered open space is significantly less than commonly believed. Future Mars colonists will be among the first. Our atmosphere is far more extensive than we typically assume.